Let's continue on with solving systems of equations for lesson 1.4a. When solving systems of equations using substitution or elimination, you may run into a situation like the following. If you solve a system and the variables all cancel out, you're either going to have a true or a false statement. A statement is true if the variables cancel out and everything cancels out, so you end up with 0 equals 0. What that means is you have the equation for the same line in two different versions. Your solution then is called infinitely many solutions, or you can abbreviate it as IMS for infinitely many solutions. If, however, you solve and your variables all cancel out, but yet you have a number on the other side, like 0 equals 8, we know that that doesn't make any sense. 0 does not equal 8. What that would indicate is that you have the equation for two lines that are parallel to each other. Therefore, for the system, there's no solution. Let's put that to the test over on the right. Solve each system using any method. So we have that first system, 3x plus 2y equals 11, and then it's negative 6x minus 4y equals negative 22. Well, the first thing I would do is move the 4y to the other side, and that way you have your variables together on the same side. So I'll subtract 4y. As I rewrite this then, we end up with 3x plus 2y equals 11. 11, there we go. And negative 6x minus 4y equals negative 22. Trying to get x or y by itself, I notice that if I multiply that top row by 2, my x's will cancel out. I'll have positive 6x plus 4y, but I also get positive 22 on the right. So what ends up happening is not only do the x's and y's cancel, meaning we have 0 left over, but on the right we have 0 as well. And because of that, we know that that would be the same line, meaning there are infinitely many solutions to that system. That's what you'd want to write out. Over on the right, however, when we do that same thing, we have 6x minus 2y equals 5, negative 3x plus y equals 7. If I multiply that bottom row by 2 this time, we would have 6x minus 2y equals 5. Negative 6x plus 2y is equal to 14. Notice on the left side the x's and the y's cancel, leaving us with 0 again. But now on the right side we have 5 plus 14, which is 19. Obviously that's not a true statement. 0 does not equal 19. What that indicates is there's no solution to this system. Those two lines would be parallel. Now let's take a look at some application. We have two word problems down below that will set up a system of equations and solve. The first thing you always want to do is actually read the word problem carefully. Maybe read it a couple of times and underline key information. The second thing you want to do is assign variables. Maybe you want to pick variables that match with the words in the word problem, or maybe you just want to pick x and y every time. Either way, make sure you know what variable stands for what part of the word problem. Once you read that word problem, you should be able to do step 3, create a system to solve. Once you create that system, then solve. After you solve, make sure your system has meaning, and we'll look at our examples to see if our solutions make sense. Over on the right, in 1 week, a music store sold 9 guitars for a total of $3,611. Electric guitars sell for $479 each, and acoustic guitars sold for $339 each. How many of each type of guitar are sold? So we know two things. We know how many are sold, and we know the cost of them. We have electric guitars and acoustic guitars. If we know how much they sell individually, we should be able to make some comparisons. If we choose X and Y, I'm just going to assign them a type of guitar. I'll say X is the number of electric guitars, and we'll say Y is the number of acoustic guitars. And that's my husband outside driving his Ranger around. Sorry about all the noise. So we know that if those represent number of guitars, how many guitars were there total? There were 9. That means X plus Y, the sum of each number of guitars, should equal 9 total sold. Then we have the price portion of this problem. Together, there was a total of $3,611 worth of guitars being sold. Electric guitars are $479 each. That means if we take $479 times X, that's the total amount you'd make for those electric guitars. Acoustic guitars are only $339 each. Therefore, if we multiply $339 times Y, that's the value of all those guitars. Together, they sold for a total of $3,611. This is your system. What I'd like you to do is pause the video and see if you can determine the solution to the system. So you're on step 4. Once you get a solution, press play and we'll see if we have a match. How many of you came up with 4 electric guitars and 5 acoustic guitars? You probably needed a calculator for this one, or wrote out some calculations on your paper, which doesn't sound like a whole lot of fun. Recognizing that if we wanted to use elimination, you could have also used substitution. Make sure to give your answers meaning, and this is what I mean by that. If we have whole number answers, that seems reasonable. If you had a fraction or a decimal, think about the meaning of that for a guitar. Can you have a 1/4 or 3/7 of a guitar? That wouldn't make sense. So for step 5, you just want to make sure your answer has meaning and if this seems to be valid for this problem. All right, let's try the last one. An adult pass for a local county fair costs $2 more than a children's pass. When 378 adults and 214 children's passes were sold, the total revenue was $2,384. Find the cost of an adult pass. Well, if we're looking for cost, we have 2 types of passes that are valid for this problem. We have adult passes and that would be their cost. And then we have children's passes. So this isn't the number of passes sold. We already know how many were sold. This is the cost per pass. Now it says in the beginning, adult passes cost $2 more than children's passes. That means we're going to add $2 to every children's pass to get the value of an adult pass. That means X equals Y plus 2. So for every children's pass, add $2. That's the cost of an adult pass. It then says when 378 adult passes were sold and 214 children's passes were sold, the total revenue, or the amount they made, was $2,384. That means if we have 378 adults times the cost of the adult tickets plus 214 children's passes times the cost of those passes, they make a total revenue of $2,384. Well, now when we look at this system, it looks like substitution would be the best method. Notice you already have X by itself in that top equation. So what we can do is substitute it in down below to solve. Go ahead and do that now and then press play. You'll probably need a calculator, so make sure you have one. And then we'll end the lesson to make sure our answer and make sure our answer seems valid. When I solved this problem for Y, I got 2.75. And again, remember that the variables represent the cost of the passes. So that would be $2.75 for a child's pass. So that's like a ticket to get into the fair. That seems like it's valid. But it did say find the cost of an adult pass. So we need to make sure we know which variable we're looking for. And we actually want to know the X value. Well, if we remember in that first equation in our system, the cost for the adult passes is simply $2 more than the cost for children's passes. So if we add $2, an adult pass would be $4.75. So adult, let's make sure we write that in there. For an adult pass. And there's a little bit of application with these systems of equations. Use both video lessons to work on your checkpoint quiz.